In a previous video, I demonstrated how to fit a normal distribution to a set of data using MATLAB. In this short video, I'm going to show you how to do the same thing in AgenaRisk and a bit more. So we start by creating a new model in AgenaRisk. I'm going to select this icon, create a new simulation node. That creates a new continuous node. Just going to make this a little bit bigger. And let's just look at the default properties here. I'm going to use this node to learn some data about annualized growth rates. So let's just call this growth. Give it that variable name. By default, it just gives it a normal distribution with zero mean, a very large variance. So that's the default setting. The distribution you can see there has got this mean 0 and this very large variance. But of course what we want to do is learn that distribution from data. And in order to do that, we've got to have a spreadsheet with some appropriate data in. And a spreadsheet then is going to have to look something like this. So here we've got a spreadsheet with a column of data and a label called growth. And that's basically all we need in order to import and learn this data. In this case, the values in here represent the annualized growth rates for consecutive quarters over, in this case, a period of, well, we can see how many quarters we got here. There were 61 quarters. So all I have to do now is select in AgenaRisk the Launch Learning tool by pressing that icon. Select Load Data from File, and I'm going to load that particular data that I just showed you, that spreadsheet. And you can see that it's recognized one variable matching the model, which is this variable growth. It's got 61 data points. Press OK there. Don't need to worry about these various values and settings here. We'll just run the learning. So it's telling me the learning is completed. And there is the new learnt model. And you can see that it's got a mean of 2.96, standard deviation 0.74992, variance 0.56, etc. I can also, by right-clicking, display the summary statistics for that. It's got the same information there. So that's all well and good, but I want to use what I've learnt here, for example, to make predictions about future growth rates. So what's the probability that in the next quarter the growth rate will be more than 4%? Well, to do that, I simply create a new node. This is a discrete node in this case, which by default is a Boolean node. Let's call this prediction. And I'm simply going to say if, and I'm going to select the parent node. So if growth is greater than 4%, then I'll say true, otherwise false. That's just using the if function in AgenaRisk. Apply that, run the model, and you can see that there's an 8.2% probability that the growth rate will be greater than 4% in the next annualized quarter. Of course, this isn't very flexible. We want to be able to make predictions for any particular value, so we'll simply create another simulation node, which is going to represent the value we want to predict that it's going to be greater than. Let's just call that x. And I'm now going to link that into the prediction. And I'm just going to simply redefine the probability table there, expression there, to be instead of growth greater than 4, I'm going to make growth greater than that parent variable, which was x. Could have put that directly, I've just picked it up by doing the right-click functionality here. Press apply there. Now at the moment, of course, I haven't given x any value, it's just picked up the default, which is itself a normal distribution. But if I put in the value that we just used, which was 4, and we run the model, you can see it gives us back the same values. But of course now I can put in any value. So let's see what's the probability that it's going to be greater than 0, for example. Well, if we look at this, it seems that it's almost certainly going to be greater than 0, but normal distributions have infinite tau, so it shouldn't be 100% certain. So let's enter the value 0. and run the model. Now this is interesting because it clearly isn't certain. It's 99.996% sure it's going to be greater than 0. It's not showing up the false value here because that's just a setting that we can change in the model. If we go to the model graph properties, you see it's only showing minimum probability value 0.01. We want to make that a much smaller value to display. Also increase the accuracy of decimal points that it's rounding to here. And now you can see it's displaying the probability of that false value of 0.00363. So that means that there's that probability that the growth rate will be less than 0. Of course, I can put in any other value here. What's the probability that we'll see a growth rate, let's say, of above 2%? There's almost a 90% chance the rate will be above 2%. There are also other features that we can show on the graph itself. If we go into the properties, go into the graph defaults, you can see all kinds of settings that we've got here. But let's just pick up on some examples here. Let's just show the lower percentiles, make that 1 and 99. And you can see now that it's actually displaying that on the graph. And if I hover over this, it's showing me that the upper 99 percentile has got a value of 4.7057. And that means that 99% of the distribution lies to the left of that value, or in other words, there's a 1% chance that the growth rate will be greater than 4.7057. Now, just one final thing here, again, something that you can do in AgenaRisk, which shows the power of the Bayesian inference. Suppose that we discover that in that month there wasn't a greater than 2% growth rate. So we actually observe that that's false. Then what does that tell us about the true growth rate? Well, we can simply run the model in this case, and you can see that, of course, the growth rate must be less than 2%. So you can see that's the true distribution.